Today, let's talk about bridge rectifiers. Bridge rectifiers are very common in circuits, especially in power supplies to convert AC to DC. Bridge rectifiers come in many types based on ratings and packages, and this is their common symbol. At its core, a bridge rectifier is made of 4 rectifier diodes. This is a bridge rectifier circuit built. This is a 220 volt to 12 volt AC transformer. This rectifier bridge uses 4 diodes with a bulb as the load. Current in a diode flows from the non-banded end to the banded end. Based on the current direction, the right side is positive and the left side is negative. This is the schematic of the rectifier circuit. Now let's look at how it works. A bridge rectifier uses 4 diodes, and AC voltage alternates in polarity and magnitude. When the top terminal is at Auger potential, current flows from high to low. When current reaches point due to the diode's forward on and reverse off behavior. The diode from ATO dis reverse bias ed and cannot conduct, while the diode from ATOB is forward bias ed and can conduct. So current can only flow from A to B. When current reaches point B, the diode from B to C is reverse biased. So current flows from the load to point D. When current reaches point D, the diodes from DO on DOC are both forward biased. But since A is at Auger potential, then D and C is the lowest. Current can only flow from D to C and then back to the transformer. This completes the circuit loop. When the top terminal is low and the bottom is high, current again flows from high to low. When current reaches point C, based on diode conduction rules, the diode from C to D is reverse biased and blocks current. While the diode from C to B is forward bias ed and conducts. So current can only flow from C to B. When current reaches B, the diode from B to A is reverse biased, so current flows from the load to D. At point D, the diodes to A and C are forward biased. But since C is higher than D and AI is the lowest, current flows from D to A, then back to the transformer, forming a loop. As you can see, no matter how the AC polarity changes, the current through the load always flows in the same direction, which achieves full wave rectification. Now let's look at the voltage waveforms before and after rectification. First, we measure the waveform before rectification with an oscilloscope. This is a sine wave AC signal. Next, we measure the rectified waveform. You will see that half of the waveform is flipped, so all output voltage pulses point in the same direction. This is full wave rectification, continuous and more efficient. In contrast, the single diode rectifier shown in the last video produces a half-wave rectified output with discontinuous voltage and about half the power lost. That's why bridge rectification is more efficient than single diode rectification. In typical rectifier circuits, a filter capacitor is usually added to smooth the output voltage and current.